Greetings to all. Hope my screen is visible to all of you. Yes?
Yes, sir.
Okay, thank you. So, in our previous session, we discussed about binary tree and the binary tree traversals. Okay, so how a binary tree will look like. Okay, so in binary tree, each tree nodes, okay, it will have two subtrees. Okay, maximum two childs. Each node will have maximum two children. Okay, so this is what a binary tree. Okay, so then how to traverse each node in a binary tree. Okay, so binary tree traversal means visiting each node and processing each node. The processing may be simply printing the value of the node in the screen or performing some calculation. Okay, so this is what traversing a binary tree. And a binary tree traversal, there are two approaches available. That is a depth first traversal and breadth first traversal. Depth first traversal means visiting the child node first. Okay, visiting all the child and successors first, then going to the next child. And BFT, breadth first means first visiting all the children of a node, then going to the successor of the each child. Okay, so this is what BFT, breadth first traversal. Okay, and in depth first traversal we have three types. There is a pre-order traversal, in-order traversal, and post-order traversal. Okay, so we discussed about what is a pre-order traversal. Okay, so pre-order traversal and what will be the output of a pre-order traversal. Okay, and in-order traversal and post-order traversal. So each the diagrammatic representation we discussed. Okay, if you are looking at the algorithm implementation, the recursive implementation of this depth first traversal algorithm, there is a in-order, pre-order, post-order. Okay, so recursive form of these algorithms are very simple to implement. Okay, so if you are checking this algorithm, see here, this is the pre-order traversal algorithm. Here, just what we are doing means we are getting the root node as a parameter. If the root node is not equal to null, then process root node. Here, processing may be simply using a printf statement to print the root node data or performing some calculation. Okay, so it may be anything. Okay, then pre-order of left subtree. Okay, so if left subtree is available, that you are passing as a recursive call, pre-order of left subtree, and then pre-order of right subtree. Okay, so what is pre-order traversal means NLR, root node processing, then left child, then right child. So we are processing the root node, then for further processing, we are passing the left subtree to the function itself, recursive call. After processing the left subtree, we are calling the function again using the right subtree. So processing the root, calling the same algorithm to process left subtree, and calling the same algorithm for right subtree over. Okay, so this is what pre-order traversal. If you are converting this into a C program, okay, so the C program will print all the content of the node in pre-order as per the pre-order traversal. Okay, so if you are checking the C code, that's it. This is what the C code. Pre-order struct node star root. If root not equal to null, printf root data. After that, pre-order recursive call. Okay, root left, then pre-order root right. Okay, how this will work, that we will see little later. Okay, so first, before coming to this pre-order traversal, let us create a tree first. Okay, see here. See here. So for creating this binary tree, we created a structure. Okay, the structure contains data and a left pointer and right pointer, because each node has will have two children, that is a left child and right child. So we have a pointer called left and right. Okay, only the name. So in double linked list we will call it as a previous pointer and next pointer. Okay, here we are calling it as a left and right. What we are going to do means we are going to store the address of the left child node in the left pointer and address of the right child node in the right pointer. That's it. This is a structure node. Okay, this structure we are creating. Then in the main function, okay, explicitly we are creating 7 nodes. Okay, we are not creating a dynamic. We are not getting input from the user and creating each and every node. Okay, for understanding purpose, now we are studying about only the traversal, not creating binary tree. So for understanding the traversal, okay, we are statically creating the nodes and assigning the pointers. Okay, we are considering this tree. Okay, here how many nodes are there means 7 nodes are there, n1, and n1's left child is n2, n1 right child is n3, and n2 left child is n4, n2 right child is n5, then n3 left child is n6, and n3 right child is n7. Totally 7 nodes we have. Okay, all these 7 nodes we are going to create in main function and assign these values. So that n1 data is 100 and n1 left child is what? What is n1 left child?
N2.
N2. The same way, n1 right child is a n3. Okay, so let us take this diagram. Okay, so this is the diagram we are going to use. Okay, so that one is for BFT traversal, but the same tree we are going to reuse it. Okay, so n2 left child is n4, n2 right child is n5. So this structure we are explicitly creating in the main function. See here, in main function I have created 7 pointer variables, then one root pointer. Okay, then n1. I'm dynamically allocating memory for each and every node. Once this pointer variable, this memory allocation is over, explicitly I am assigning n1 data equal to 100, n1 left equal to n2, and n1 right equal to n3. Then root node equal to n1, because the first node is the root of the tree. So I am giving root equal to n1. After that, n2 equal to 200, n2 left is n4, n2 right is n5. See here, n2 left is n4, n2 right is n5. Okay, like that, explicitly I am assigning the left node, right node values and data values. Once this is completed, I am calling the pre-order function. Okay, I'm calling the pre-order function. Now let us comment the in-order and post-order traversal. First, let us see the pre-order traversal alone. Okay, now this is over. Now I am calling pre-order of root. Okay, so root node is pointing to n1. Okay, so n1 will be passed to the pre-order function. First, n1 will come to this place. Okay, first n1 will come. Okay, now it will check whether n1 is not equal to null. Yes, correct. n1 is not equal to null. If n1 is not equal to null means printf n1 data. What is the n1 data? n1 data is 100. Okay. After printing 100, it will go to pre-order of n1 left. Okay. What is the n1 left?
N2.
Left is n2. So n2 will be this n2 will be passed to this pre-order traversal. Okay. Now n2 will come. Okay, and n2, is it equal to null? No, n2 is not equal to null. n2 value is a 200. So 200 will be processed. So first it printed 100, then it will print 200. 200 will be processed. Again, n2 dot left. Okay, what is n2 left value? n2 left value is a n4. Okay, so n4 will be invoked. That is n2 left will be invoked. That is n4. Okay, n4 will be invoked. Okay, and n4 will come to this place. Now n4, is it equal to null? No, it is not equal to null. It contains some value. So printf n4 data. What is n4 data? 400. See here, n4 data is 400. Okay, n4 data is 400. So after printing 400, it will go to n4 left. Okay, what is the n4 left?
Null.
Null. So n4 left is n4 left will be invoked. It is null. So it will go to null here. Okay, and the root equal to null. Yes, it is correct. Null. So this if block will not be executed. It will go to the previous call. Okay, n4 left means its previous call is n4. Okay, so it will check for n4 right. Okay, what is n4 right? n4 right also null. Okay, n4 right. So this will come to this call. Here now n4 right. Okay, n4 right will be invoked. This is also null. Okay, now since n4 right is null, this will be go to the previous function call. So before n4 left and before n4 right, we have n2 left. So n2 left, it is having right child. Okay, what is the n2 right? Now n2 right will be invoked. n2 right is a n5. Okay, n2 right is a n5. So n5 is a 500. So n5 will come here. Since n5 is not equal to null, it will print 500. It will print 500. And n2 left. Okay, n2 n5. Okay, n5 left is a n5 left will be invoked. It is null. Okay, since it is a null, okay, the if block will not be executed and it will go to n5 right. Okay, n5 right. And n5 right also null. So it will go to the previous function call. Now what is the previous function call means? Before n2, n1 is there. Okay, so now it will go to n1 right. Okay, n1 right is a n3. Like this, the recursive function call will work. Now let us check the output of this program. Okay, now what is the output we are printing? 100, 200, 400 and 500. Okay, it's not fully completed. Okay, See here, 100, 200, 400, and 500. The same way if you are processing means the remaining output will be executed. See here, 100, 200, 400, and 500. The same first four outputs be traced now. Okay, if you are tracing the same way, we will get 300, 600, and 700 as the output. Okay, now suppose if you are unable to trace this, follow this means we can check this function this way. Okay, so first we are calling pre-order of 100. From main, we are passing root. The root is the N1 node. Okay, it will go to the N1 node and it is not equal to null. Okay, so this is the first function call. Okay, it is not equal to null means printing the root data. That is N1 data. So N1 data is 100 now. Okay, after printing N1 data, okay, the next function call is pre-order of root left. What is root left? 200. That is pre-order of 200. Sorry, pre-order of 100 left is 200. Okay, pre-order of 200. Okay, pre-order of 200 means 200 will come. Okay, and since 200 is not equal to null, it will print 200 here. It will print 200 here. Again, after printing 200 data, 200 is left. What is 200 is left? 200 is left is 400. Again, pre-order of 400. Okay, pre-order of 400. Okay, pre-order of 400 will come here. So and it is not equal to null, so it will print 400 data. Okay, so 400 will be printed. Then 400 left. Okay, the 400 nodes left node. Okay, 400 node is left node is what? It is pre-order of null. Okay, pre-order of null. Okay, and since it is a null, okay, it will go to the it will return the previous call. What is the previous call? 400 is the so 400 left is the previous call. So this function call, okay, this will be removed from the queue. Okay, this pre-order of null will be removed from the queue. Okay, again the function call will come and join in this place. Now 400 write. 400 write is what? Again, it is a null value. Pre-order of 400. Let us write like this. Okay, 400 write. It is a null. Okay, since it is null, this also will the if condition will not be executed. It will go back to the previous function call. So this block will be removed now. This function call will be removed now. Okay, and since left and right of both 400 is completed, the if condition is completed. So the 400 function call, this will also be removed from the stack. Okay, now it contains 200. Okay, 200 left actually. Actually, so far we processed 200 left. So since all the left childs of 200 is processed, this 200 will be removed now. 200 left will be removed now. Okay. After 200 left, what is the function call available means 200 right. So insert 200 right. Okay. And 200's right node is 500. Okay. 500 means the 500 the 200's right node is 500, and the 500, since it is not equal to null, it will print the 500 data here. The 500 will be printed. Okay, then the 500's left node. Okay, 500's left node. Okay, and the 500 left node will come to these places, and the 500 left node is null. So the function call will be returned. Okay, and the 500 left will be removed from the stack. After that, we have 500 right. Okay, 500 right. Okay. And since 500 right also null, the if block will not be executed, function call will be returned. Okay, so 500 right will be removed from the stack. Okay, and both the left and right of 500 is executed, and 200's right also. Okay, 200's right is the 500. Since that also completed, the function call will be returned to 200 right. So 200 right will be removed from the stack. And the pre-order of 200, the 200 also removed from the stack. Okay, now pre-order of 100's right. Okay, left everything, all the child is left is 100 left. It is completed. Now 100's right. Okay, 100's right. The 100 nodes right node. Okay, what is 100 nodes right node? 300. Okay, since 300 is not equal to null, it will print the data 300, and then it will call 300 left. 300's left child will be invoked. Okay. Now, what is the 300's left child? 600. Okay. 600, since 600 is not equal to null, it will process 600. Okay. 600 is processed. And then 600 is a left node. Okay. 600 is a left node. Okay. What is 600 left node? It is a null. Okay. Since it is null, it will be returned. So it will come to this place, and the 600 is a right. Since 600 right also null, that will also be removed. And finally, the 600, both left and right is removed. Okay. And since the left side is completed, 600 is fully completed, the 300 left also will be removed from the stack. Okay. After 300 left, we need to insert 300 right. Okay. 300 right. Now, 300's right node is 700. 700 will come here, and the 700 will be processed. It means that 700 will be printed. Okay. Then 700's left and the 700's right will be processed. Since it is null, the 700 means the if condition will not be worked. The function call will be moved to the previous call, and finally 300 will be removed from the stack, and 100 right fully processed. So this also removed from the stack, and finally it will be means the control will be transferred back to the main function. So this is how the output will be printed in the screen: 100, 200, 400, 500, 300, 600, and 700. See here, 100, 200, 400, 500, 300, 600, and 700. Okay, so this is how the pre-order function will work. Okay, pre-order. Pre-order means root node first, then left node, and then right node. So first root node 100, again 200. Its left child is 200, and 200 is a root node. So 200 will be printed. Then its left child 400, and for 400 there is no left or right child. So it will go to the root node and its right child 500. So 100, 200, 400, and 500. Then 300, 600, and 700. So this is the output. Okay, pre-order. If it is a in order means, see here, if it is a in order traversal means first we need to visit. Okay, in order traversal means first we need to visit the left node, then root node, and then right side child. Here the process, first we are processing the left subtree, then processing the root, then processing the right subtree. Only the order of the statements we need to change. Okay, the recursive function calls order. Okay, that we need to change. That's it. See here the C code. Okay, first in order root left, then printf root data, and in order root right. Okay, see here. Okay, now let us comment. Okay, so what will be the output means? See here, first left subtree, then root, then right subtree. Okay, it is a root, so it's a left subtree. Again, this is a root, so it's a left subtree. So 400 will be processed first, then 200, then 500. Okay, then 100. Since all the left subtree is processed, root node 100. Then right subtree, and right subtree is again root, it's a left subtree 600, 300, and 700. So the output will be 400, 200, 500, and 100, 600, 300, and 700. So this is the output for in order traversal. Okay, let us check the output now. See here, 400, 200, and 500. Okay, so 400, 200, 500. After that 100, then right subtree is the left child, 600, 300, and 700. 600, 300, and 700. So this is in order traversal. Okay, the same way how the post order traversal will be executed means, okay, for post order, okay, first we need to process the left subtree we need to process, then right subtree we need to process. After that we need to process the root data. Okay, first left, then right, after that root data. So the output will be output for this example. Okay, first left subtree, then right subtree, after that root. Okay, so for 100 we have left, and again 200 is the root data, so it is having left. So left subtree is a 400, then right subtree is a 500 and 200. The output will be 400, 500, 200, then 600, 700, 300, and finally 100. Okay, let us check it. Okay, so still not uncommented. Okay, now let us check it. See here, 400, 500, 200, 400, 500, 200, okay? 600, 700, and 300. 600, 700, 300, and finally 100. Finally 100. So this is how the depth first traversal, in order, pre-order, and post-order traversal will work. Okay. So understanding it may be little bit difficult. All the function calls, recursive function calls, will be stored in a stack. Okay. So whenever a new function call is happening, the previous details of the function, okay, it will be stored in a stack. Over that, the first function call. Over that, the second function call. Over that, the third function call. Okay. So first to the third innermost function call will be processed, and its result will be transferred to the previous call. Okay, like that it will work. Okay, so stack is used in all the recursive function call. Okay, please keep in your mind that stack we will use in recursive function call. Okay, so this is how the pre-order, in-order, and post-order traversal will work. Okay, next BFT, breadth first traversal, how it will work. Okay, for that we are not going to discuss the program now. Okay, we will see the concept first. Okay, in our next session we will discuss the program. Okay, so tree BFT. See here, in breadth first traversal, okay, keep in mind in depth first traversal we will use recursive function, and the recursive function requires stack. Okay, in stack the recursive function call will be stored, but in breadth first traversal BFT we will use queue concept. Okay, how? Let us check it here. Okay, now what is breadth first traversal means? Suppose if you are processing a node, after processing all its child nodes must be stored in a queue. Okay, suppose if 100 is there means, okay, first 100 you need to enter into queue. Okay, 100. Okay, and then all means we need to 100 is the current node, and 100's child nodes, that is 200 and 300. 200, 300 you need to enter into the queue. Okay, you need to enter into the queue. Then process the queue until it becomes empty queue. So print 100, then print 200. Okay, while processing the 200, check whether 200 is having any child nodes. Yes, sir, 200 is having 400 and 500. So in queue 400 and 500 here. Okay, 400, then 500. Okay, now 100 is removed from the stack. Okay, 100 is removed from the stack and printed. 200 is removed from the stack and printed. And the 200's children's. Okay, so all the children are added in the queue. Now the next node is 300. In queue, all the child nodes of 300 in the queue. Okay, 300 having two children. There is a 600 and 700. In queue, the 600 and 700. 600. Then 700. Okay, 600 and 700 be processed in the queued in the queue. Okay, now 300 is processed. Okay, 300 is processed now. The 300 process means we need to process 300. 300 is processed. Okay, and the 300 children nodes are added in the queue. So now the next node is a 400. Okay, but for 400 there is no child node. Okay, so simply remove the 400 from the queue. Next is a 500. Okay, so 400 must be processed. 400. Okay, the next is a 500, and 500 there is no child node, so directly we can process the 500. 500. Okay, and we can remove it from the queue. 500. Next is a 600. Okay, and the 600 also there is no child node. Okay, 600 will be processed. Sorry. And 600 also no child node. Okay, so 600 we can remove from the queue after processing. Now the next node is a 700. Okay, 700 there is no child node for 700, so no need to enqueue any data. Directly we can process 700. Okay, 700 we process now. Okay, 700 we process it, and 700 we can remove from the queue. That's it, over. So this is how the BFT, first traversal, will work. Okay, if you are taking a node, all its child node must be added into the enqueue into the queue. Okay, whenever you are dequeuing a node from the queue, enqueue all its children node in queue. Okay, now let us go to the algorithm. See here, BFT traversal algorithm. Okay, so this is the algorithm. We are passing root of the binary tree to the algorithm, breadth first traversal. See here the algorithm. Okay, first set current node to root node, create a queue. Okay, we need to use queue to process the binary tree using breadth first traversal. Iterating, okay, current node not equal to null. Until current node not equal to null, we need to perform the iteration, process current node. Here, what is the meaning of processing means? We are printing the data of the current node. So print first node, current node, then check its left subtree is not null. If left subtree is not null, add the left subtree value to the queue, NQ left subtree. And the right subtree also not null means NQ right subtree. And if queue is not empty, set current node to DQ. Okay, from the queue, you remove the first element and consider that as a current node. Okay, else set current node to null. It means that until the queue becomes empty, we will perform the processing. We will perform this iteration. So this is what breadth first traversal. Okay, so this is what breadth first traversal. Okay, so binary tree traversals we discussed in yesterday's, means in the previous session, and the implementation examples. Okay, so implementation examples we discussed in today's session. Okay, so this is what binary tree traversals. Okay, in next session we will discuss about the expression tree concept and then BST, binary search tree. Okay, expression tree means converting the given expression into a tree. Okay, and after that, if you are performing the in-order traversal, you will get infix expression as output. If you are performing the pre-order traversal, you will get a prefix expression as output. And if you are performing post-order traversal, you will get postfix expression as an output. So this is what expression tree, advantage of expression tree. Okay, and binary search tree means here directly we store the values. Instead, for binary search tree, there is a condition. Okay, all the left side values, it must be less than the root node, and the right side values must be greater than or equal to the root node. Okay, so that is what binary search tree condition. So based on the condition, we will perform the insert operation into the binary search tree, and we will perform the searching operation. Okay, so that is what binary search tree. That details we will discuss in the next session. Okay, so now